So now we're over at your second generation machine now,
Yes.
the newer version bought, and I see in here you have some other options on your work holding.
Yes.
Looks of a higher density. Can we have a look at some of these?
Yeah, absolutely.
So on here, I can see that there's a much bigger density of components on here. So obviously on here, you're not using the chick system.
No.
No. You moved to this. So please explain a little bit about why you've not used the chick on here, but also what you've done with the design side this here.
It's really down, as you said, Steve, to your density, how many parts we need to manufacture per week to keep up with what we need down in the assembly department. So for us, we found that around about 150 units a week would be the optimal.
Yeah.
So we were able to manufacture these in the rate of 30 at a time. So we've got a first station on two faces and we've got a second station on the other two faces.
Yeah.
So effectively we're putting raw material in and we're taking out finished parts at the other end. So having this surface space to work from allows us to achieve one run every single day, which gives us the 150 that we needed each week. Because we're running aluminium and aluminium solely, we don't need to have a full steel tombstone.
Yeah.
We can have the aluminium tombstone, which is, when you get larger, the weight obviously increases. So we've got a maximum weight capacity that we have to consider when we put it in and out of the machine. So having this hollow, but still really structurally reinforced strong aluminium units, we can actually achieve really good speeds and feeds. We can machine this whole system in just over an hour and 10 minutes, but start to finish, both the first and the second op. And it gives us really good rigidity and really good results, because what you may see from here is these are gear pockets.
Right.
Gears are ground.
Yeah.
Really high accuracy. That's how our punch system achieves the figures that we tell our customers as they buy them. So we have to ensure that these are machined within a few microns. So actually, even at the top versus then at the bottom, we can still achieve really good results. We don't get any movement and we really don't see any variation. If I was to give that, or I was to give that to the inspector, he really wouldn't know which side of the system it had come from. So it's really secure. That's what we really want.
I think that's the benefit of the Abbott Tombstone is using the Tensorloid material. Yes. You've got a real good thermal, stable, strong product, haven't you?
We have, and it was really easy to machine in its first place. So facing it down to size, putting in the holes, putting in the reinforcements, because we knew that when we started to use the OK Vice systems and the grips, that we were going to end up with quite a lot of force going in to hold all of the fixturing in the right place. So once we machined all of that and we put a cap onto it, it was really quick, really simple, and it was a really nice, easy fixture to put together.
You're using different clamps on this side. So on this, on op one, I see you're actually utilising the little knife edge clamps from OK Vice. So the interchangeable jaw on that side.
Because we didn't want to be wasting too much material, being able to grip just along this sort of face, which we did learn by error slightly, that we didn't leave enough on there. So we actually machined some of the pads that these sit on with the hardened end mill, just milled them back slightly.
Yeah.
That gave us a little bit more. So advice to anybody looking to use the system is give yourself as much meat as you can to clamp on.
Yeah.
Because what you'll find is that these guys will dig right in, and if you don't have enough support behind, it can just pull it away slightly.
Yeah.
So give yourself a good amount of clamping space.
You're looking around about that 3 mil, aren't you?
We are, about 3 mil, and we can then machine exactly what we need out of that billet, which means that we're not spending loads of extra money on extra materials. So that's a really nice advantage to using the system. And for us, once you then come to take the fixture apart, around about 27 Newton meters we actually do these out. So you can see you've got your teeth marks at top and bottom, so we are in again 2 to 3 mil, and that is your finished product. Very easy to blow out, very easy to clean and put back together.
There's nowhere for the saw to sit, is there?
It really isn't. It really isn't. So we tend to take them down together in groups. So we actually start from the top and work our way and keep them all in order, so that when we put them on the second side, they all go back in the same order. So we can roughly say to the inspector which position these units have come from when we want to. But again, we've had really very few of these units, and where we have, it's actually down to loader error. When you put them in, you are just lining that up with our stop, holding it in place, pistoning it up, and you'll feel it grip and then you get around about 1 turn, and that's now around about 27 newtons. If you wanted to, you could quite easily check that. And that gives you loads of force. We run around here, and we don't mill this in a standard pattern. We'll actually take very, very small cuts.
Recoil machining on this one.
Absolutely. So we get lots and lots and lots of swarf coming through. We do it really quickly. And like I say, it's just over an hour and 10 minutes for the whole fixture. We're not keeping it very slow.
It's impressive for 30 components, you said, isn't
Yes.
it? That is very impressive.
So this takes us a little bit longer to load
Yep.
than we would say with one of the other fixtures, but that's purely because of the quantity that we're running through.
Yeah. So you're going to have one pallet in the machine being machined, this one being loaded, so it's no downtime as such.
No.
And on this side, Paul, obviously on your finished side, the components are sat back further, but you don't want the grip in there as much. So you're now using the little Uniforce clamps, which are there for finished components, aren't they, really? So
really no marks left on them. Again, loads of clamping force, so we don't have any issues with any parts being released. They're, again, very easy to blow off and keep clean. They don't really require any maintenance other than just making sure that anything in behind is blown out and cleared out. Once the fixture's clear, it's really quite easy.
Yeah.
So for us, I'll go up from the bottom because this is our singles at the moment. Again, you can see how easy and straightforward that is. You've got
no mark
nice clean on top. And we actually treat these with what I would say, without giving too much away, like a clear anodizing.
Yeah.
Goes into marine environments, but it needs to have treatment. So for us, I don't want to be having to rub anything down or go through 30 components top and bottom with a bit of Scotch-Brite. So we can literally take that. It's absolutely fine for what we require, blown off, stored in a box and sent out for treatment. And then what we get left with, again, is a really nice simple system, which you can take your half-finished component, put it in, slicing it up, and that's it, set, ready to go. And when you come and do your checks, as operators should be doing when they're using the system, you can very easily go around and actually check every single component really quickly.
Yep.
We can see in the fixturing doesn't get in the way too much, so you can make sure that everything's sat back properly and it's all enclosed. It's all the right way around, and away we go.
And you've got all the access you need, haven't you? So
absolutely.
Again, we're not going back to that single component and eccentric vice. You've got all the access you need to machine your components, and a lot of them in one stage.
Yes, yeah, we can achieve quite high quantities for very little effort going in the machining end. If you were to do this in a vice situation, you would have 30 vices, whereas you can see how quickly with one screw, 2 whole components are coming out, and that's quite manageable for one person.
Very
straight out. So you can change this a lot faster than you ever would having single vices in a standard machining setup.
Yeah, and I say with production running on this side, how long's this one been in the machine running as such for?
Just under 6 years. This would have been about a year into production. We actually introduced this one. So it's done for 4 to 5 years worth of machining. We've not had to replace any of the fixturing. We've even been able to, in places, do just a small little bit of machining just over the top of the fixturing, just to allow us that additional little bit of recovery and clearance. And none of those units have failed whatsoever. We've had no issues where the springs have gone or any of the clamps have worn out. The teeth certainly don't require filing or sharpening or anything like that. They are the original units. And if we did have anything that required any type of maintenance like that, we simply just unscrew the whole unit straight out.
And drop it out, yeah.
Just drop it out. You can give it a clean. You can buy your spares if you need them. You can just put it straight back in, screw it back in, put your parts in, and it will clamp itself just like it was before. So it's really easy to look after if you do have any machining mishaps or any type of wear and tear. But we really haven't seen any of that at all. And like I said, we've been using it every day for the last sort of 4 to 5 years with really good repeatability.
Good. No, that's brilliant. Thank you very much.
If I show you what we do with some of our cast iron units.
That's impressive.
Still an aluminium base, which we've used our own fixturing components to create the geometry that we need to hold each unit in, which are hardened, screwed back. But of course, this then does utilize various types of clamping techniques and methods. Biggest challenge for us is overcoming the fact that, as I said earlier, castings do tend to vary. Especially with us, with these particular components, is that they are filled from the top. So they'll take those castings, put them up against a grinding wheel, take off your slag part that you just simply don't need. So they do tend to vary in height. So for us to be able to put your Mighty Bite system in, put that part in, clamp it down, torque it up, you get a really good repeatability.
Yeah, so that's using the pit bull with a knife edge, isn't it?
Yes.
So you get that grab and pull back each time to real secure holding.
And one thing I hadn't really realised before using the system is that because you've got a pivot point in the back, as you're tightening those parts up, you'll feel it engage, and then you'll feel it bite in, and it gets harder and harder and harder and harder to move, and you know you've got yourself in the right position.
Yeah.
If the clamp itself isn't fully clamping into the material, what you'll feel is it'll hit a really hard stop.
Just go straight to a lock, doesn't it?
Go straight to a lock. And that's because it's reached the back of the hardened part as opposed to actually connecting fully with the component. At that point, you know, you take one out, you put the next casting in and you tighten up. So the risk of you ever tightening this up and not realising that it's the part or the fixturing you've clamped to and not the part is really hard to do. So as long as you teach and train your guys and girls how to set these up properly, they're really quick and straight and easy to operate. So we've got our first operation. Again, we have a couple of sides that look the same, so you'll notice this is identical. Again, first side, so we've got 5 on the first operation, 5 in the second operation, and then 5 in the final operation. And we employ a range of different clamping options. So having this quick release system allows us just to undo our clamps, and we just move them out to one side.
They just swing out the way.
And they just slide straight off. And because these are put in on the first operation, we guarantee that we actually locate these holes with the centre line hole in exactly the same place every single time. So we can really easily and quickly take these components off, load the next components on.
All in exactly the right position.
And exactly
just to run again.
Again, repeatability is huge. We see it come through all the time. We really have no issues with any movement on the fixture, top to bottom. We don't have any release issues. So yeah, the clamps are really, really good, really, really strong. And you'll know that you've reached the right clamping pressure because as you start to over clamp, what you'll find is it will start to pull away slightly and lean back. So as long as you keep those clamps in a good right angle, you've got full force without any problems. And then we take these from our second station into the third station. Again, a similar idea, but we've got your lobe. So effectively 1/4 turn. That undoes, which I should be able to famously now demonstrate. So, as you see, 1/4 turn, that comes out. Again, we are drilling a G1/2 inch threaded hole into the bottom. So we've got lots of force going through the system. We then thread mill the unit out. But if we just make sure that we have this whole pad clean, the unit goes back in again. Obviously, this would be before you've machined. And then all we're literally doing is just making sure you've reached that lock, that your lobe is no further than your 6 o'clock position, because as soon as you go past your 6 o'clock, you start to loosen again. And that's now fixed in.
And perfect.
So I think it probably takes longer to clean the fixture because of the complexity of it than it does to operate any of the clamping systems.
Yeah.
They're really easy. And we've used this, again, really from the start. We have exactly the same on the other one. So we have simply repeated this process. So we've got 12 to 13 years worth of use out of the unit over here. This has got 6 years worth of use. And as I was saying to you off camera earlier, for us, all we are doing is changing out the M8 bolts once every 6 months, just because they get so much wear and they're holding all of
they'll
this.
Start to mushroom and lose their shape.
We just change those out, put fresh ones in. For the actual clamps themselves, we've probably changed 3 sets over a combined 20 years use, and that's all we've ever had to do.
Yeah,
and that's only relating to these.
Yeah,
and the others stay fine.
Yeah, they're running 24/7 a lot of time.
They
and
run
as you
once
said,
a night,
you
every
are
night.
heading this really hard with some of the new tooling you're using.
With CBNs, with ceramics, so we're doing really high speeds and feeds, 3-4 mil depths of cuts.
Yep.
In the same 250 grade cast iron, and we have no pullouts whatsoever, no issues whatsoever. And we are drilling from the front all the way through coolant drilling. with 11.5 mil drill, so it's a good size drill, a good amount of force. But we aren't really restricted too much. None of the clamps stick out too far. They aren't in the way. And other than ensuring that if you are tightening up, that you're not leaving them too bent over, that you keep them in a nice straight line.
And that vertical line there.
You're not going to have any issue with any interference with tools or spindles or anything like that hitting the system. So really, really flexible. So we use this for our outlets. We use a very similar system for our inlets. So as we had over there, we have two different types, an inlet and an outlet. This is the V5 version, so the later versions. Exactly the same process.
Yeah. Yeah, you've really utilised multi-work part holding, haven't you?
Yes.
Again, really moved it on.
As we've said quite a few times today, we'll put a fresh billet in, we take a finished part out. So every single process, we're machining 30 and receiving 10 every single time fresh as we take it out of the machine. So we can up this if we want to, we can rotate inlet to outlet, we can run that all day if we wish to. So we had a big order coming through, we can really easily maximise how many of these we manufacture in a working day. And it's very straightforward.
Very, very impressive. Thank you.
You're welcome.
Thank you for your time today, Paul. It's been really interesting with this. Looking towards the future plans,
Yes.
do you think you'll be using a similar ethos and product for what you're going to do with your new fixturing plans in the future?
Absolutely, yeah. Seeing the benefits that we've seen over the 10 years, how well they've lasted, how easy they are to look after, the fact that you're not just limited to such a small range, really the world's your oyster. You can find clamping and fixturing for anything. As we evolve from the older machines and we try more of the pallet-based machines, as production increases, there'll be loads of opportunities to bring more of that clamping technology into what we use every day, keeping it quick, keeping it consistent. So yeah, absolutely. In short to your answer, we'll definitely be using far more going forward.
Good, great. Thank you for the time today. Thank you very much, Paul. This has been Steve, 1MTA at Hydraulic Projects, and with Paul here. Thank you very much.
Thank you very much.